So this question, you have got a CD player where this is the beam of light, beam of laser light. It goes into the transparent plastic layer, hits the reflective layer here at B and hits the reflective layer at A and reflects back off and comes this way and comes back this way. Okay, now the reason why CDs are designed this way is to create some sort of interference between the reflected rays so they register as destructive or constructive when they are received here. That allows them to create a code of zeros and ones that then will be decoded as a sound signal. So what we've got is you'll need to calculate the wavelength of light in air using Snell's law. And then this here, it gives you the light reflected from point A is 180 degrees out of phase with light reflected from point B. We know that when we are 180 degrees out of phase, we know that is half a wavelength in terms of path difference. So we know that the path difference is equal to a half wavelength when the waves are out of phase. So when the waves in A are 180 degrees out of phase with B, when they arrive back here, they are half a wavelength out of phase. So when they arrive back here, A will be out of phase with B by half a wavelength. Okay, so that is the reflection takes place in the transparent plastic layer. So we asked for this depth here. Okay, now half a wavelength is 414 divided by 2, which is equal to 207 nanometers. Now that means that the distance has gone there and back. Okay, so when A hits the reflective layer, it hits that point. So the wave has traveled this distance there and then that distance back. And that there is the extra distance that A has traveled over B. So that distance there and back to the same level as B is equivalent to half a wavelength. So what we need to do to find the depth is half that. So it would be 207 nanometers divided by 2, which is equal to 103.5 nanometers as the depth. Okay, so when it says 180 degrees out of phase, that means that the path difference, we know that we don't even need to look at the question itself. We know 180 degrees is half wavelength path difference. So when we work that out, that's the path difference between A and B is 207 nanometers. Now, A has traveled this distance and this distance in addition to B. So if 207 is nanometers is that distance, therefore that would be half to find the depth of 103.5 nanometers.